Hello, everyone, and welcome to today's Solution for Mitigation AC Interference webinar led by our very beloved and famous Joe Pikus at Technical Toolboxes. My name is Kesley Price, and I am the Product Marketing Manager here at TT, and I will be facilitating the webinar today for Joe. So we'll get started here shortly with Joe's introduction, but first, a couple of logistical details I want to get out of the way and cover first. If you have any questions on what Joe is covering, what he's demoing, there is a chat box, or it shows as a questions tab in the top right of your screen in the webinar interface. Please feel free to send us any questions you may have throughout the entire webinar, and we will do our best to cover all those questions at the end. We will also be sending out a copy of this webinar recording to all the registrants and attendees via email within the next couple of days. So you'll see that in your email. And then also on our YouTube channel, we will post this webinar recording. So I know we get asked that a lot. It will be available for you to view again and share with your other team members or whoever you desire. So please submit questions throughout and we will get those at the end. But let's go ahead and get started, Joe. I'll turn it over to you.
Well, thank you, Kesley, and welcome everyone. And I do like questions, so that's okay. So let's begin. And what I want to talk about before we even get started is the uh, we're gonna go over a little bit about some basic stuff, and then we're gonna get into I'm gonna talk about this thing called, oh, it's gonna move on me, conventional versus advanced power conductors and stuff like this. And we're going to do a live, but I'm going to show you a few things first, so you could get used to what you're going to see when we do the live show, and to show how easy it is to use. So let's start with AC interference. And if you see this photo on the right, this is up in New Jersey off US Highway 1, just outside of, it's near Edison, New Jersey, Woodbridge Township, that area. Uh, I don't know if anybody recognizes it, but you could see the pipeline markers there, the yellow markers. There's a 30, 42, and I believe a 12-inch in there. So just FYI. And how do I know? Because I did some AC mitigation in this area, and I just happen to know this particular area. So understanding AC, the key risk running near high voltage power lines, we already got a problem already, and then they're going to use these advanced conductors and increase the power up to 3 to 4 times what they're doing now, without changing the towers and all the other stuff. So this is what I'm talking about. So this is why I brought this up. Uh, uh, they're looking to do about 100,000 miles. So be prepared. There's been a few areas that already have these systems in. So and they don't have to tell you, because they're going to say, "Hey, we're just replacing wires. Watch out for that." And guess what? Because of the power, the 3 to 4 times, even if they're not on your right of way, or you're on their right of way, um, guess what? They could be a quarter mile away and still have interference. So watch out. We're going to talk about the power tool. This is what we call it, the AC mitigation power tool. We'll talk about the steady state, induced steady state voltages, the volts, and then we use ArcGIS. I just want to give you guys how it's done here. And then we'll talk about an enterprise package, with expanded features for complex projects. In other words, we'll help you guys. We'll do some consulting with you, sit down with you and help you with the result and the interpretation. And then we're going to do that live demo, and then we'll, like Kesley said, we're going to do Q&A. Okay, 60 years ago, believe it or not, I started in 66, and 1966, not 1866. Don't take it too far back. But the company I work for was already doing fault currents. And how do I know? When I first got into corrosion in '69, uh, they were on top of their game. They are already using lightning arresters and spark gaps on a 30-inch line, and this was done in the '50s, by the way. And it was set up based on proximity within 10 foot. If the tower leg was within 10 foot of the pipeline, they installed these devices. So just FYI, everybody says, "Oh, we never heard of it, AC. We didn't know about this or that." And the reason for it was because there was a failure in Philadelphia on an oil line. Happened to be Sun Pipeline at the time, and that started the whole sequence way back then. HCAs, which we talked about, which we just saw, underground facilities in urban, and some of these are known and unknown. We should know where they all are. We should know what type of utilities are in there. We're way beyond these days to today, and pipeline operators uh, just don't have many choices. Where to install pipelines, as you've seen in this right away here. It's 30, 42, and a 12-inch. Not much room in there. So you could see how you could get in trouble. And then these utility corridors, with the mixed electrical systems and everything else, from a land perspective, yeah, it's a good engineering and economic sense. But how about for us? So that's what we're dealing with. Um, let's see. I want to go back here. So the key risks. I hate when this is preset and I talk too much. Understanding AC interference. Basically, we have to keep the current densities down. Once these power lines are uh, put in, these advanced conductors, you're going to see things that you never could believe. So, and that's what I'm going to show you. What the modeling shows too. Using this type of uh, currents, yeah, and loads and so on and so forth, using in, the peak loads, and we're going to be talking about the peak loads primarily, not the maximum loads, the peak loads, and there's a difference between the two. And coding, and then the coding and pipe damage from faults, which I just mentioned. So we have to think about uh, all aspects of it, and the impact on pipeline integrity. I was going to submit a paper to AMP or NACE for next year, but somebody beat me to the punch. They said, "Oh, there are already some papers um, in the AC portion of the program, and you're too late." So, but maybe I'm not too late by us doing these type of webinars and things of this nature. Maybe you have heard it, maybe you haven't. I don't know, but we just want to bring it out and say we're ready for it. So the impact on pipeline integrity and of course the public and personnel safety is the major thing. Uh, I'm gonna I'm gonna turn that right now so it doesn't trip on me. We use ArcGIS. This is what we start with. With our program. So we could bring in uh, the information that's needed. We also use we're using the of course AC current density using the AMP criterion or criteria, and then the Barnes layer, the same thing. We're using 3 different layers. We're also using the single and combined graphics, your choice of presentation. You can import and export a lot of the data very easily with spreadsheets. Ease of use, the modeling and mitigation is in hours, not days. And this is what surprises a lot of people uh, that we work with. Probably the hardest part sometimes is gathering up the data. Getting those KMZ files, getting those shape files. from the power company, and so on and so forth, to import them. That probably tell you that could be a pain in the neck sometimes. But the modeling, the nice thing about it, if you could do it in hours, you could do a lot of what if scenarios very quickly. If I put this type of mitigation there or that, and we'll show you that in a little bit. We can view before and after mitigation. In other words, what we just updated was a little checkbox. So if you've been working on it and you got a lot of mitigation, you want to look back, just uncheck the checkbox or check the checkbox, and then you can go look back and see what it was when you started, which is pretty cool. You could download the data for additional studies, and then you could select your input and output data on the reports. That which is nice. You don't have to always get a 50-page report. You could narrow it down to maybe 10 pages of the stuff you want to look at, and then training based on your needs. We'll hang in there as long as you are. So don't worry about it. The other thing we need to be looking at is, you know, uh, we are one of the leading providers of integrated software, engineering software for pipelines. We have right now we have over 10,000 users. Not companies, but users using the software. So just to let you know, so we're on top of our game at this time, and then we do on-site training, which I'll be doing by arrangement, as needed. So we have done that, live in-person events, online webinar events, and then AC mitigation webinars. So keep that in mind. Some of the things that we offer. I'm gonna jump ahead and show you one of the examples that I'm going to show you in a little bit. Uh, these these this pink and different colors here, the live demo, and is where the mitigation or the faults are, and the type of mitigation. This legend will tell you if it's red, it's a discrete anode. Pink, it's a distributed anode, and of course, if it's blue, it'd be a parallel placement or a linear anode, or ground. I should put my grounding hat on, my AC hat, and stop calling them anodes. If you're CP, we could call them anodes. For AC, we should call it grounding, even though they're the same thing, um, and the same equations, believe it or not. So anyway, we'll be talking about this and how this is done and everything else. And we do it on an ArcGIS map with and this is the fault mitigation. So I just want to show you that. Okay, and then we're going to go over here, and this is the ArcGIS map. I kind of scrunched it, for the purpose of the power, but this is an unmitigated using conventional power conductors, and this is the mitigated one, and as you could see, uh, we got three places. We got the discrete, we got the mitigate, the distributed, and the distributed over here, and we knocked the heck out of the. This is the mitigated. Okay, yeah. So this is the unmitigated. Yeah, here we go. It jumped ahead. This is the unmitigated. You can see this is 70 volts. This is it mitigated. Hard to believe. We're down. We're down. The induced voltages on this are down in a single numbers up here. What we took, the blue line is the voltages, and the green line is your current density. So your current densities, if you look over here, are well over about 120, about 130 amps per meter squared. Look at it now, your current densities. This is what we're dealing with. This is pretty cool when you could do something like this and put in the mitigation and we'll show you how that could be done in a minute. And then we're going to move over to, I really want to show this because this is, remember this 70 some volt, about 75 volts or so? Look at it when it unmitigated advanced power conductors. It's driving it up over 200 volts. It's just unbelievable. Look at the current density. The current density is over 400 amps per meter squared. This is your induced current, okay? And everybody asks the question, why do you guys do the induced current? Well, guess what? You need to know that so you can size your conductors when you're doing your modeling for mitigation. In other words, if I'm going to use a linear or a wire placement, um, I need to know what size cable to use. If I'm using a copper cable. So we have to look at that. Where's my maximum current going to be? And once you mitigate, everything changes. So when you come down in here and you knock it down from whatever it is here and knock it down into single numbers and bring your current density below 30 amps per meter squared, we also got to look at the induced current. Oh, get back there. So so if I'm jumping around here, we're just probably about 90 volts on induced current. Look what happens to it when you tie it into mitigation. It almost doubles. So this is why you need to know how to size your decouplers, how to size the wires that you're doing and things of this nature. So this is why I bring this out. We're going to get into some detail. Here we have the discrete. And in this case, there's a station up here, and I'm going to show you this later in a little bit on a live map. Uh, we put the decoupler across the isolating flange into the station. So we could put that as a discrete anode. This is distributed and all the way through, and we're able to handle it, which is nice. And then we're going to move off this, and I'm going to do a live presentation with the same thing. And I'm going to go with AC mitigation. Let me just refresh this since it's been
Hey Joe, while you're refreshing the screen, we got a question that I think would be a good time to answer now instead
sure,
of at the end.
absolutely.
Is AC modeling used only during the design stage when an AC interference is expected, or there are other benefits for such?
Uh, it's you could do it in an advance in the preliminary stage. Uh, that's one thing if you could get the information and so this is one of the things you should do anyhow. Uh, uh, regarding all of this because there there there's 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 good reasons. Oh, you notice how I changed my map around? I could flip it around. I have the capability to do that. Zoom in. And regarding uh, you as long as you know what the soil resistivities are, it's a great question. As long as you know what the route is and where the power line is located, this could be a preliminary. This could be a preliminary um, design, and yet it could be the final design because once the pipe is in, then you could go and verify exactly what the models are predicting, and and we have ways to tweak it to represent what's out in the field. And what I mean by that is remember the voltages on the towers are changing all day long, because of their load, right? So so because they are, you're going to have a daytime load of X, and you're going to have a nighttime load of Y, and everything in between. You're going to have seasonal loads. You're going to have all these different things. But what do you design for? Do I design for peak load, max load? What do I do? Or do I do you know what it's operating at 2 o'clock in the afternoon? You know what and it's location, location, location. I'll give you an example. Duration. When here in the Houston area, we have much longer uh, uh, demand because we start off with 80 to 82 degrees in the morning, and then we go up from there. In our daytime temperatures, up to sometimes 8 o'clock at night, or 9 o'clock, versus up in the north of this area. They have much shorter durations. Uh, Even though they have 100 degrees, it's not 100 degrees all day long. So keep that in mind. That these are the kind of things you need to think about. Great question. So it can be done anytime, before, during, and after, and you should, because once you get your mitigation in, you want to see what's going on. So here's that compressor station, or station I was telling you about, where the isolating flange was, uh, and then here's power line coming in, and I'm just using this as an example. I try to mimic the real world here, and where do we put our section lines, or where do you want to put our nodes? Anytime there's a change in direction of either the power line or the pipeline, and each time there's a change in soil resistivities, major changes, anytime there's changes in transpositions of the systems of the power lines, uh, anytime you cross a road or waterway or things of this nature, or anything that you think that is going to impact, the system itself, knowing your own system. And this is why I like using the maps, because you could get down into the detail that you need. Because remember, your designs are going to be based on, can I put it in? Can I cross that? Okay, I got a crossing. Am I going to directionally drill it in, or am I going to just stop on each side of the road? And these are the kind of decisions you, the pipeline operator, or whomever engineer, has to make. And so this is what it's based on. Here's a foreign line crossing, and then additional roads, and so on and so forth. So when I create these section lines, it doesn't take much to create them. It's just a matter of turning this on. If you're dealing with a 20 or 25 mile line, it would take you about 20 to 25 minutes to, and it's just a matter of, say I wanted to put one right here, and all I have to do is click and point, and there it is. I could draw all these in about 5 minutes. If I want to get rid of it, I could just delete it. It's that simple. And then what we do is we calculate, once we put where we think our nodes are going to be and where the changes are going to be, or we could always come back and modify it. But this is where we would calculate the angles and distances. This is where we get the information. So you don't have to go out there. You physically don't have to go out there. You could do a lot of this stuff, uh, right. You can model it right then and there. And it give you, and this is what a lot of people do. Uh, and they go back to the, if you have a third party contractor doing it, they'll go back to the pipeline operator and say, hey, did you guys think of this or that? They'll bring up stuff that sometimes the pipeline operator hasn't thought about in these designs. So these are the kind of things that we look at. And when the power line starts leaving the right of way, there's concern there too. So we need to be thinking about all of this. And how do we get this information in here? Remember, I said we use ArcGIS. So I have an ArcGIS map. Okay. So I'm going to bring that up. Let me go up here, and it's basically the same thing. I'm gonna I'm gonna I'm gonna cover the areas with. Okay, this is down at the lower end. Okay, here we go. So I'm gonna move it the way I want to see it, and this is the nice thing, and you can see the power lines the way they go, and so on and so forth. And all we do is import these guys in and drop them in, as a power line, and we put it in as a pipeline, whatever it is. This is nice. The reason I use this because you could see the right of way very clearly of both the power line and the pipeline. I just kind of drew them in. So that's where I got the information. These are not my pipes or I've done any. I just drew them in because it was easy to see and use. So because I was familiar with this area. So 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 this is the nice thing about something like this, is you put the information in, and then you could easily uh, light it up. What we do is light it up, and then we drop it in here. That's all we do, and it's just a matter of dropping it in with this little mapping tool right here. See, select power line from map, and that's all I got to do, and it puts it in that quickly. So there's ease of putting all this. The biggest part is gathering the information. I hate to say it. So this is why I bring this up. Um, the other big question that uh, a lot of we get is what about your what about the put the pipe diameter, the burial depth, and you could import it in. We just put this to start, and your coating resistance. We have tables for that, and your coating thickness. You should know what that is. This happens to be an asphalt enamel coating on this line. So it's a little thicker. But let me go to the section lines, and then we use the Barnes layer. The deep layer is about 100 feet. That's up to you what you want to put in there. The corrosion or pipe layer is the depth of the pipe, and then the surface is the surface. And this is what we're using. We find that the Barnes layer is the most common. How can I say it? Probably the most universal one to use throughout, for the calculations, because of the flexibility of it, and it's more representative of the real world instead of curve fitting and doing all other types of things. So this is why we go that route. We're using the actual data itself. Once that's in there and you have your lines drawn after about 20-25 minutes, you're ready to calculate. Wow, isn't that fast? We hit the button, you know, we already calculated our angles and everything. And let's see, this is already mitigated, so I'm going to unmitigate it. So I'm going to disable mitigation. Remember I said that we already mitigated this, and so I'm going to disable it, and then I'm going to go here and calculate the unmitigated one, and then we can look what we started with. Similar to what I showed you earlier. Okay? The blue line is your induced voltage, the green line is your current density, and there's your induced current up here. And here's your scaling over here. AC current density, induced current. The red is induced current. Pretty cool. Now, if we want to go back and let's look at it again, I'm going to go back in here and disable, and then I'm going to calculate, and I'm going to do my settings here. I'm going to go to my access. I'm going to do mitigation. I'm going to save and apply. There's my mitigation. Ah, so I got some blue, and I'm going to turn this on. Isn't that cool? And it'll show the mitigation. And that's why I turned my map around so it matches over here. So what I'm saying is this is what I showed you earlier. So this is your discrete anode. This is your distributed. This is the distributed right here, and then here's the blue one right here, and there's your linear or wire placement uh, grounding. And this is how it's done. Oh, you want a report? Okay, we could go up here and run a report, or I could run it right here. And if I don't want half of this stuff, I could just take it out, just to generate it real quickly, just to show you. And then we're going to compare it to the advanced conductors. Okay, as soon as it runs the report, I just want to show you one, and that's it. Takes a few seconds. So uh, if I printed the whole 40 or 45 pages, it'd take a little longer. But I should have centered this. But I should have, if I centered this, you'd have the whole thing in here. Here's your data, and so on and so forth. And then when it has it, it already has the mitigated since I already did it. So it put it in there already, which is nice. And it even shows you where the anodes are located, what node they are in the report, which is nice. What type they are, where your mitigation is, what nodes they are. I think it's a pretty cool report. And then all the other information. I'm not going to run through it. You don't need to see all that, but uh, that's the kind of stuff we have. Now, let's go with the advanced conductor.
Hey Joe, while you're on the
Yeah.
screen, we got a question. Would you mind showing us where you get to AC mitigation in the toolbar at the top?
Oh, yeah, sure. Thing called corrosion.
There we go.
Okay.
Thank you.
How
Yeah.
about that? Yes. Thank you. And in here we have AC mitigation steady state, AC mitigation fault, and we got the Google map version and we got the GIS version. And if you want to play around with those, which you can do, you could do that. And then we got our string down here, and then we got some workflow stuff and other stuff. But this is where you would bring it up, and so case yeah, I didn't even think about that. Thinking more on the technical end. Yeah, this is our pipeline toolbox, and oh, we have our cathodic protection in here. So if you guys wanted to determine a single anode, for the calculations in the AC mitigation, you could use that, or single horizontal, multiple, and so on and so forth. So we have that in there. We're going to integrate this in the future. The CP with right into the where you go to mitigate. So so you could see it popped up. Now all of a sudden we got a lot more mitigation, don't we? You know, to knock this down. We only had it in three places. Now we have it one, two, three, four, five. But remember those real high voltages to over close to 200? Look what the mitigation did. it knocked it right down. Like I said earlier, I showed you. This is basically the same graph. Okay, pretty nice. And here's your induced. I'm sorry, your AC current density, and it's all less than 15 amps per meter squared. And this and by you selecting the locations, the peaks, and we could go back again. I could go back to the yeah, I could disable again, calculate. Always wait. There it is. This is what we this is what we knocked down. Unbelievable that you could knock this down. So the point I'm making is I'm going to go to the power lines here, and let me turn that on. And this is we were calculating 1500 amps. Okay, now we're calculating 4500 amps per phase. Okay, so this is what I wanted to point out. We need to know these kind of things because they can really influence things. So even if this power line wasn't on this right of way all the way, it actually is. I didn't run it all the way through. It goes in and out and over and so on and so forth. I just took it to a certain point. But you should always run it all the way through. But I just wanted to show you how what could happen. I want to show you how easy it is to run these scenarios. Uh, you could have 100 nodes. Some people have 400 nodes. Depending on the length of the pipe and so on and so forth. But I just wanted to show you the ease of coming in here, and when we're ready to do the mitigation, we have three ways to do the mitigation. Remember that first one? Discrete anode right here. I put it right in there. You could use all three of these if you had to. They're there to be used. There may be situations in low resistivity environments. When I'm talking about low resistivity, less than 1,000 ohms centimeter. I've done some work down in Barranquilla, Colombia, and there we were dealing with 200 ohm centimeter soils. Talk about they've already had leaks, from that low soil resistivity. Doesn't take much voltage, a couple volts, and you're in trouble of AC. Even even across here in the Brazos River, just east of Houston, 30 ohm centimeter brackish water. They had a leak with a half a volt of AC. Yeah. So, and you could see it arcing. They said they saw it. The diver saw it arcing to a clamp. And the same thing we observed up in I'll say the Northeast in a casing. It was a high voltage AC system, 500 kV. And inside the casing was water. And where when they were taking off the boot of the casing, it was found by a smart pig. The guys could see where the pipe was in very close proximity to the casing. They could see it arcing it through the water. And you're saying, well, oh, that's fresh water. No, when you're dealing up in the Northeast with a lot of salts and things of that, chlorides, to melt the ice. Inside those casings where it accumulates, it's actually the resistivity of that water is much lower. I've tested it. That's how I know. So So these are the kind of things. And then let's see, where else did we have mitigation? This is section 3. So I'll go down to section 3. And you notice I put in, where the distributed anodes are. Section 4 should be the same thing, and so on and so forth. So this is how we mitigate, and we can mitigate in. It's easy to mitigate. If I wanted to put more mitigation in, I would just put it here, and then just drag this thing down, and just say I want it from 7 to 11. And once I put these values in, whatever it is, parallel. Here, I'll just do something like this. Here we go. Oh, I should have. Let me release it. There we go. But I know what's happening. Yeah, I left it sitting too long. But anyway, uh, the key is the ease of able to use all this and go from there. So you would just drag these down and go like that, and so on and so forth. Okay, so so we found out. And how long do you think before you would have a leak in this area with those kind of current densities and voltages? It wouldn't be long. Let's do faults real quickly. And faults are easy. We already got the data. Once you model it in a steady state, all you do is bring it in. Okay, this is in Thailand. Okay, so let me get out of Thailand and get into the real world. Oh, they got problems there. They got like real low resistivities, and they have uh, I don't know if they got advanced conductors, but they got high power systems. I'm sure they do because advanced conductors are now all around the world. But here's the same thing. So I'm gonna turn this around, zero in, drag this open, which is nice. You could size it the way you want. Once you do the work. Uh, and so what I did is with the advanced conductors, I put in 15,000 amps going either or a total of 30,000. And I just split the difference because I wasn't sure where I didn't see any power stations nearby or substations. So I just split the difference on the shield wires. Um, and it's a 345 kV line, and we're going to use wire number 3. And we don't have wire number 1 working, so I'm putting that out. And so what I'm going to do is calculate and see what see how this works. And the reports are basically the same. I should just center it better. Oh, did it calculate? Maybe it did. Oh, so there it is. Calculated successfully. And it put and how did I get this faulted tower? Well, it's the closest tower to to the pipeline. So I come over here. I think it's section 10 or 11. Yeah, let me see. 10. Yeah. So it depends. So here we determined it was number 10, and we had 800, just a little over 800 volts. Uh, uh, and I could tell you the difference between this and the original one. Let's disable. Let's take a look at the unmitigated. And where do you see that? Remember 800 volts. How about almost 5,000 volts? So, what does that tell us? What are we seeing? We could mitigate some of these things. And what are the and what are the what's the surface potential rise? About 9,000. Step potential is about 9 volts, and then the touch potential is about 43, 61. So so this will calculate all your information regarding the safety and really what we're looking at is this didn't take any time to set up. All we did is look for the case that we created in the steady state version, brought it in. The mitigation that we did for steady state happened to take care of this area too. So we didn't have to put any additional mitigation, and we kept the voltage low, so we don't have any create any little pinholes in the coating. And that's another story. Uh, One investigation I did where we saw a lot of pinholes at adjacent to a tower, and they needed to mitigate it. These type of areas. What I'm going to do is come come to a conclusion here. Is that be aware of a thing called advanced conductors. They are There's already projects on the works around the country. There's already some that were put in already. So look out for them when you see these guys replacing wires. Find out if they're putting advanced conductors in. It's hard to tell the difference unless they tell you. Um, we have ways to estimate um, the voltages on the power lines based on if you can't find the information, based on the number of discs on the insulators. But we don't have a way to estimate the load factors. You have to go to the power companies and get that. And we do give you some information to get you started. We have defaults in the program, and we always recommend to go with the peak loads. That's the one that's most optimum for estimating, what's going on. We recommend that, and that's usually 3 times the defaults. It could be a little bit more, a little bit less. I've seen it both ways, but it's just over 3.1, 3.2, even up to 3.3 in some cases. Uh, but uh, but you can figure some of this out. Other things we do we give you a lot of information uh, that to estimate your coating resistance and things of this nature too. The length of time the pipe was in service, you could estimate it that way. The type of coating and so on. Any questions before I?
No, I think this is good, Joe. And as far as I know, we offer some consulting services to help with some of these projects, correct?
Yeah, yes, we do. And let me go back to this guy here. Uh, let me go from the beginning. And I think I mentioned that in here. Yeah, right here, pre-project, consulting software, consulting, results, interpretation. So we do a lot right here. We could do even on site by arrangement. Uh, live in-person events, online live webinar events, and so on and so forth, like we're doing now, and then AC mitigation webinars. In other words, this is how it works. If you sign up and you want to get the AC program, AC Power Tool, you would get one of our engineers, and they'll set you up, and we will work. We basically, even if you're not going to buy it right away, we'll take one of your projects and work with you right through it. I'm doing this. I've done this to multiple companies. I'm doing it to another big company right now with all their people. And this is what we do. We work side by side with them. And they say, "Well, what about this, Joe? Or what about that?" Have at it. We'll work with you on it. We'll get you going, and we'll stay that way. We have programs that you could ask engineering questions, and in most cases you'll get an answer within a day. If you're on top of the world, you've got one of our other arrangements. Um, you could get within a half a day or less. So depending, uh, and I know people sometimes call me, and I'll answer. I'll take care of it. But we prefer you going through the system, so we could track on what's going on. I have to write it up anyhow if you guys don't go through the system. So please do. So even though you got my number and email, please go through the system, and that's one of the things we do. Let me just close. Let me
Great,
show you.
Joe. This is
Yeah,
this is all good
yeah,
stuff. We do have one poll question we want to get to here pretty quickly.
sure, sure.
Yeah, yeah, yeah. So we just have one quick poll question that'll display here for about a minute. We're just, asking what you'd like to learn more about so we know how to take the next steps with you, whether you have no interest, if you're interested in the AC Mitigation Power Tool, which obviously Joe demoed pretty in depth here today. We'd love to do a one-on-one demo for you or for your team. So if that's something you're interested in, please mark that one as what you're interested in, and we will get you some more info and even tailor a demo to you. The second option is the AC Mitigation Enterprise Plus package. That is what he just spoke on that last slide. So we offer everything with an experienced SME dedicated to your team for everything from pre-project consulting to how to properly use the software to results interpretation is all covered in that Enterprise Plus package. We also have in the top right of your screen, next to the chat and questions tab, you'll also see a materials tab. There you'll find some more information about that consulting package that we offer in addition to our AC mitigation power tool. So feel free to check that out.
Yep.
Um, Again, if you have any questions for Joe about his demo or presentation, please submit those now and we will move over to those next. All right, Joe, we do have some questions here for you. So
Okay,
first one being, it's a little long, so let me read it out, okay?
go
So
ahead.
I've noticed that some systems have been designed so that zinc earthing anodes are connected directly to a pipeline without using a solid state decoupler or polarization cell replacement. Is this considered an acceptable practice? If so, are there any criteria to consider such a practice?
Uh, Yeah, well, thank you for asking. I worked with Dr. Dubkowski with I was involved at POCI for a while, when I was a pipeline operator. And when when this was done 35, 40 years ago, we're actually using that same engine, believe it or not. Um, they started with zinc. Okay, why did they use zinc? Well, because they didn't have one of the old polarization cells that came out, using a liquid. What is it? uh, to dissipate the AC. In other words, uh, I want to say it's some hydroxide, but anyway, um, that's how they started. And the reason they use zinc because zinc was a way to protect the pipe at the same time. And of course, the problem with the zinc ribbon, it dissipated quickly. They put it in. If there was no decoupler or polarization replacement cell or any of those things that we have today, we uh, uh, the zinc is going to just get beat to death, because there's not much zinc there, and it has a steel rod in it. Since then, remember, uh, power companies used to use zinc grounding 75 years ago or even more. No power company uses zinc grounding anymore. They use all copper, and that's why. And so, and in addition to that, Dairyland has developed, uh, all these different cells. Yeah, we don't have to we're we don't have to worry about chemical spills, with the old systems that were developed. We don't have to fill them anymore. You didn't have to get splashed on or wear protective equipment, with some of those old cells the liquid cells that they had. And they would dry up and everything else. Everything could go wrong with them. Now we got everything that's solid state. Um, so 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 we could use any kind of grounding we want once you get your type of cell sized and bring it in. If it's greater than 45 amps, you better start looking at different types of cells and stuff like that. So keep that in mind. So yes, uh, zinc is that's how zinc got started, uh, because we didn't have a way to decouple it, and it was actually used for CP. And if you had a rectifier and ground bed system, that even exacerbated because you could polarize it too, and it'll go flat on you. In other words, once it once it's polarized, then it won't work anymore. So you got to watch zinc. That's all I got to say. Uh, that's my experience with it.
Thank
Great
you,
question.
Joe. It does look like we have another one here. I want to, common question. Will these slides be available for the audience? So we do not distribute our slides except for our training courses, but for these product webinars, we will have this available, this recording on our YouTube channel in the next 2 days, as well as you will receive this as an attendee, but also registrants who couldn't make it will receive this recording via email. So that will be available to you within 48 hours, but we do not provide the slides.
Yeah,
um, all right, Joe. I think that's all we've got. You answered most of the questions throughout the
yeah.
presentation. Feel free if you didn't have time to answer your questions, or maybe if we've missed something, please reach out to us. Um, we appreciate you joining the webinar. Joe, thank you for the presentation. Again, if you have any additional questions or interest in having a one-on-one demo for you or your team, Joe and our other in-house experts would love to talk to you. So please reach out to us at Technical Toolboxes. Thank you and have a great day, everyone.
Actually, I have a ending slide here,
Oh,
right there.
perfect.
Okay. So we covered this. Thank
Yeah,
you.
that's how you can contact us. Thank
Yeah,
you all.
and that liquid cell was potassium chloride that nobody's using anymore. So forget about it. Okay, I'm trying to forget about it. Have a good day. I appreciate everybody. Thank you.
Thank you.